Okay. So, review day, huh? Yeah. So, let's close this part. Let's go through this practice test. So, if you did have a chance to sit down and kind of try it, you'll notice it's a lot of work, right? And so, first thing, right, it's going to be really important that you don't waste a lot of time on the short answers, right? Learn from your practice test mistakes and start with the short or with the long answers on the test, right? Worst thing that happens is you rush through and you end up just filling in these boxes without actually having time to compute anything. That's for part marks, right? So that's still worth part marks. At least if you do it right, I'd say 1.5 out of 2, right? So just filling in those boxes is worth 1.5, assuming that it's right, right? And then just the answer is only half a mark, right? And so the other option is just writing down your answer. That's all you need for full marks on the short answers. But I'd probably just gamble with filling in the boxes. Pretend that you do it just at the end. I wouldn't start with the short answers because you're going to need a lot of time for these long answers. Okay? It's long, not because I like to make it long. This is actually even shorter than like the rest of the department does. So, because I think it's really, really long. And so I'm trying to stick with everyone else. I can't have super short tests compared to everyone else. Just slightly shorter. Oops. That's all I can do for you guys. Okay. But you will want to keep up your speed, right? On the plus side, the long answer questions, right? These are the types of questions to expect, right? These short answers, they can be anything, but they're all pretty similar, right? You read through them, they're all pretty similar. So, all right, let's do it. Practice test number 3. We are going to start with the long answers, of course, because you don't want to get caught not having enough time. Because I'm going to talk around these, of course. All right. Any questions before we start, though? Practice test number 3, solutions. So I've got it in here. So I'll just kind of steal it. Unless it says you have to use the formulae, plural of formulas, formula, then you can use your calculator for these calculations, right? So we're just going to go through doing it by hand and then also how you would do it on your calculator, and then you can choose, right, which way you prefer to do it, okay? You'll see on the questions, right? Question 4, for example, it says in your answer, and use your calculator, do not use formulae, right? So there we don't have an option. Question 6 is the opposite. You have to use the formulas and not your calculator. You can check your work with your calculator, right? But for marks, you have to show all your work by hand. Okay? And for the other ones, I'll give you both of the options and then you can pick. Okay. So let's start here. Ugh. Got some smudge on there. All right. Jim purchases a mortgage with a $60,000 down payment. You had a similar one on your Moodle quiz, right? Where we make a whatever percentage down payment, right? How much interest do we have to pay? Where you have to figure out the payment amounts and then figure out how much is paid in total, subtract that from, or subtract the owing from that total to figure out how much interest. You guys have done the Moodle quiz, I'm sure. It's not due till Friday, but I'm sure you've already done it. No. So here we've got a down payment situation, right? And so he pays end of the month payments of $2,000 for 25 years. If the interest rate is 4% compounded quarterly, what was the original value of his mortgage? Meaning how much did he borrow, right? So he paid $60,000 down, right? And then these $2,000 are paying off some amount that he owes, right? And so let's just go through and highlight here. We've got 3 things that we need to highlight for this test, right? Because this test is only on annuities, chapter 6 and 7. And so, okay, so he's making end of the month payments, right? And we're compounding quarterly. Right? So just like before, I'll just start here and our mode, if we're working on our calculator, would be the end, right? But that just means that we have an ordinary annuity, right? So just run of the mill, things are being paid at the end of each month, right? At the beginning, we would have to use the other formulas. Our payment frequency, payment per year, is monthly. So 12 payments per year. Our compounding frequency is quarterly, so 4. Because these are not the same, right, we have to calculate I2, right? Which means we have to move from a compounding frequency of 4 to a compounding frequency of 12, right? And so here, this is F1 and this is F2. And this is always true, right? Your compounding frequency is your F1 and your payment frequency is your F2. So just to play it safe, I would go through and list this information, and if they're the same, then you can say, phew, I don't need to do any extra work, right? I don't have to find I2, but I guarantee you will have to find I2. So they're not the same, so that means that we have to know, okay, well, R1 is 0.04, so I1 is R1 over F1, right? Our periodic interest rate, when we're compounding quarterly, is 0.04 over 4, nice and tidy, 0.01. Now we can calculate I2. I2 is 1 plus I1 to the power of F1 over F2 minus 1. This is the only formula for I2 that you'll need in your long answers, right? Your other I2 and the R and the effective rates, those are more short answer stuff, right? But this is the formula for I2 that you need to use. Okay, let's plug these values in. 1 plus 0.01 to the power of 4 over 12 minus 1. Where did I put my? So 1.01 to the power of 4 over 12 Remember, I put my 4/12 in brackets. It probably works if you don't, but I don't think I've ever tried. -1 makes 0.00332228.4. I'll store this in 1. Okay. So from now on, this is my periodic interest rate, because now I can pretend that I'm compounding monthly and making payments monthly. So let's make our timeline. And even if you're using your calculator to solve these, I still want to see I2, right? I still want you to calculate I2. Otherwise, it's not fair marking wise, or it makes it very difficult marking wise. So it's going to be part of your timeline. So let's do our timeline. So today, and then he's making payments for how long? 25 years. I'll put it up above, right? Because we're making monthly payments. Right, so how many payments is that? That's 25 times 12 payments, so 300 months. And 1 month, 2 months, 299 months, ... And we know that he's paying off $2,000 at the end of each month. How's an easy way for this question to change? The payments are at the beginning of each month. What would happen to our timeline? Not much, right? Except all these payments would have to get shifted over 1, right? So you have a payment here, payment, 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 and no payment here to indicate that everything's at the beginning, right? So that's one thing that could change. And that's true for all of these, right? Can be beginning or end. That's an easy tweak, right? Okay. So these are all paying off some present value, right? If we're paying off a loan, that loan amount is the present value. So these are all going to go and pay off some present value. If we add his down payment of $60,000, we have the total value of the home, which I think is what we're for the mortgage. All right, all right. I'll take it one step further. So we're just looking for the present value, but why not show off a little bit? So here, N in annuities is the number of payments, right? N is still time times the frequency. So 25 years times monthly payments is 300. We actually had to do it already to get that 300 months, but we're just showing our work here. So this here, just so you have kind of a clear line, right? Everything that we've done so far, this makes up a complete timeline. Okay. So I want to see all of that on your test. Okay. So our calculations aren't that bad. We did all our work in our timeline, right? And so we've got the present value from our formula sheet is the payment amount times 1 minus 1 plus I to the negative n over I. Our payment amount is 2,000 times 1 minus 1 plus, and our I was, I recall one, 0.00332284 to the negative 300 over that same 0.00332284. I'm just going to skip straight to it. So plus 1 to the power of 300 negative 1 minus that divided by recall 1 times 2,000, 379,431.0628. Mortgage amount is 379,431 and 6 pennies. That's not the same as 2,000 times 300, is it? 2,000 times 300, that's 600,000. That's how much it cost him to borrow $379,431.06. Right? So I'll throw this in optional. The total value of the home is the present value plus 60,000, 379,431.06 plus 60,000, $439,431.06. Just touching, yeah.
So for your FB,
For the FB. So in these situations, right, the future value of the loan is going to be 0. Right. So, oh, I just wanted to just quickly talk about your Moodle quiz because I have had a couple of questions about it already. Right. So on your Moodle quiz, you're going to have something similar, right? But it's kind of, it says you buy a house for 600,000 and you make a 25% down payment, right? Then you need to pull out that down payment amount because you're not borrowing that amount, you've already paid it, right? You're borrowing the leftovers, right? And so that's the total amount that you have to borrow and pay off, right? But same situation as this. Okay. How about on your calculator? Or on your calculator, I'll list them like this. And interest per year, present value, PMT, future value, payments per year, compoundings per year, and beginning or end. N from your timeline is 300. The interest per year is 4. The present value is the one that we want to solve for. Your payment, I'm making payments of $200 or $2,000, right? So it's going to have to be negative 2,000. And then like we just said, so the future value, once this is all paid off, there should be no amount owing. just like if we're starting to save some amount, our present value would be 0, right? And then we're building up from there. Our payments per year were 12 and our compoundings per year were 4, and we are at the end. And so we get solving for this. I'll just 379, 431.06. I'll just highlight this. This here, this one line replaces all the work that we did below the timeline, right? So it replaces all of this here. You can either do this, right, or actually up to here, or here rather. Yeah, you can do this by hand or what we just did on your calculator, as long as you're showing your work and all these slots are filled in correctly, that's worth the same amount of marks, okay? Because you got to the same answer. Right? So, making your calculator a little bit more valuable. Okay. Any questions about that one? Yeah, so you're gonna, so 300 and then into n. Okay. And then 4 into the interest per year. Right. And then you go through and you do, so 0 for the present value. But we can, is there anyone else who doesn't remember how to use the calculator functions? So maybe let's just talk about it after class then. Yeah, because we've been doing them for a while now. So any questions about that one? How about, what's another way that this question could take a twist? What if we're saving this amount, right? We're saving this amount for 25 years, let's say. And then we would have a future value, right? How much would we have at the end of this 25 years? And then what if I gave you another $1,000? Then what's the total that you're gonna have, right? So that's the same situation, right? I'm calculating a future value instead. I'm tacking on some other additional value that I get at 25 years. And then I'll have some total amount saved, right? That's the same type of question to me, right? Just future value, present value. So how about question, I guess 3 then? Long answer. Ted purchases a plot of land for $200,000 with a 15% down payment. Okay, here we go again. He then makes end of the year payments for the next 18 years to pay off the property. Assuming that interest is 3% compounded weekly, what are Ted's payments? So here we have to calculate some payment amount, right? You're gonna have to calculate a payment amount. So first of all, let's highlight, okay, so we've got, he's making end of the year payments, right? So our payment frequency is yearly and our compounding frequency is weekly. So as far as our mode goes, we're in the end mode again. Simple tweak would be, he makes payments at the beginning of each year or the beginning of each week. Okay. Our payments per year is 1 and our compoundings per year is weekly, so 52. because it's weekly, compounded weekly. So this would be F1, and this would be F2. Because F1 is not the same as F2, we have to calculate I2. Right? R1 is 0.03. So I1 is R1 over F1. 0.03 divided by 52. Yikes. Something tiny. 0.03 divided by 52 makes 0.000576923. So then I2, 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.000576923 to the power of 52 over 1 minus 1. Point 0.03044.562. I'll store this in one. How about our timeline now? Once we've calculated I2, we can do our timeline. So, starting today, what's happening? Ted purchases a plot of land for $200,000 with a 15% down payment. And then he's making payments for 18 years. So let's start at the top here, today up to 18 years. I guess he's making yearly payments. Yeah, end of the year payments. I didn't have to write it so high. 18 years, that's nice. 1 year, 2 years, 17 years, ... Remember, I have to see these 5 ticks, right? Today, the end point, 1 before the end point, and 2 after today. Right? Otherwise, it's not complete. Okay. And we're making end of the year payments of some amount that we're trying to figure out. So we're just going to say PMT, 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 PMT. All of these are going to pay off some present value. We know that the total, right? So he bought this plot of land for $200,000. So the grand total value is $200,000. But we also know that he made a down payment of 15%. So 200,000 times 0.15 is 30,000. So he made a down payment of 30,000. I can make a note here. Down payment is 200,000 times 0.15, which is 30,000. We can't have 2 unknowns, right? We can't have an unknown payment amount and an unknown present value, right? But knowing that the total amount is 200,000 and I've already paid off 30,000, right? I can find the present value, right? So the present value of the loan, so the present value is going to be 200,000 minus 30,000, which is usually 170,000. So all these payments, these unknown payment amounts, are paying off 170,000. Right? Great. This here is your complete timeline. Not sure why I gave myself that little room, but whatever. So we've got an ordinary annuity. Yeah. You could do 200,000 minus 30,000 equals 170,000. It doesn't matter. But as long as they're adding up to 200,000 one way or another, it's good, right? And as long as you're showing that these payments are paying off the 170,000, then you're good. Yeah. But yeah, there's a couple of ways that we could have set that up. Okay. So we have just an ordinary annuity. We don't have the present value due, right? If the payments were being made at the beginning of each year, right, we'd have a present value due, right? But we only have a present value, so we know we have to use the present value formula to calculate our payment amounts. It's the PMT times 1 minus 1 plus I to the negative n over I. We know our present value has to be 170,000, not 120,000. Is the payment amount times 1 minus 1 plus, and where did it go? Call 0.030445562 to the negative, oh, I forgot to fill it in. N is 18 years times a frequency of 1, 18 payments. So negative 18 all over 0.030445562. So plus 1 to the power of 18 negative 1 minus that little guy, oops, divided by recall 1. So I get payment times 13.70183957. So now we can solve for the payment amount. It's 170,000 divided by 13. No. So 170,000 divided by that guy, I get a payment of $12,407.09316. He must make payments of 12. Oh, what happened here? 12,407 and 9 pennies, which I reckon answers that question. What are Ted's payments? That's it. What if we wanted to do this one on our calculator, right? Or and interest per year, present value, payment amount, future value, payments per year, compoundings per year, and beginning or end. I always start out all lofty and then it gets more and more crammed. So we've got our N, which is 18 payments. Our interest per year was 3. We already found our loan amount, right? That's part of our timeline, right? So that's for everyone. And then our present value must be 170,000. Positive, because we're getting that amount, right? We're putting it towards a house or this property right away, right? But from the bank perspective, we're getting this money, so it's positive. We're gonna find our payment amount, right? So I'll just put a little star there. And then once we've paid off this loan, the future value is 0. Our payment frequency was 1 and our compounding frequency was 52, and we're at the end. Okay. So once we do this, we find that they're the same. Surprise, surprise. Any questions about that one? No. All right. Let's see here. What you'll find is some of these are easier than others, right? But they're all worth 10 marks, right? All these long answers are all worth 10 marks, right? 10 in the little square box, as opposed to a different shaped box. Right, and so figure out which ones you like to do, lock those marks in, and then move on to the more difficult 10 marks. And that's on purpose, just so you can have high marks. Okay. So here's kind of a weird situation. So Felicity leases a new truck worth $50,000. She puts a 25% down payment, then pays $1,500 payments at the end of every month. At the end of the lease period, the vehicle is worth 15% of the original value before the down payment. What was the lease period in years to 2 decimal places? Assume interest is 4% compounded bi-weekly. Include a timeline and use your calculator. Do not use the formulas. I repeat, do not use the formulas. It would take forever. Or it would take way too long, I should say. It's possible, but it would take way too long. Okay. So probably the hardest part is mapping out this timeline, right? And so first thing we're gonna do, right, is we're gonna say, okay, well, let's highlight this information. So she's making payments at the end of every month. And interest is compounded bi-weekly. So let's just jot down. So we're at the end. Okay. And the payments per year is monthly, so 12, and the compoundings per year is bi-weekly, so 26. If that 26 doesn't come naturally for the bi-weekly, right, just make a point to memorize it because you'll need it. Okay. This is the same as F1 and this is the same as F2. These aren't the same, so we have to find I2, which means we have to first find our I1. So R1 is 0.04. So I1 must be R1 over F1. 0.04 divided by 26. 0.001538462. store that. I2 is 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.001538462 to the power of, bless you, 26 over 12 minus 1. To the power of 26 over 12 minus 1. 0.0033336325. I'm going to store that right away. I guess I don't need to store it because we're using our calculator. I'm making you calculate I2 for no good reason except I want you to. Because I find if we have too many kind of, oh, not in this exceptions, basically, then you guys get sloppy. So I'm just going to make you calculate I2 always. All right. Now we can do our timeline. So what is this going to look like? So let's start today. And we'll start breaking this down. So today, and then she's going to make payments for some unknown amount of time, right? But we're making end of the month payments. So here's 1 month, 2 months for n minus 1 months up to n months. Dot, dot, dot. Because we want to find out how long is this going to take. So, all right. She's making payments of $1,500 at the end of each month. So we start here at the 1 month mark. So 1,500, 1,500, 1,500, 1,500. Okay. Here's the twist, right? So this is a lease, right? So when you return a lease, you haven't paid it off, otherwise you get to keep the truck or whatever it is, right? And so you usually have to make a down payment here, right? And then you're borrowing some amount, right? But then at the end, you're not going to have that paid off, right? It's still going to be worth something, right? You're still going to owe some portion of the original cost, right? What that's going to look like is something like this. So over here, you've got your, let's say, how do we want to set it up? Do we want to subtract from the 50,000 or add up to 50,000? It really doesn't matter. Let's be consistent. Consistency is key. The total value of the truck is the 50,000. Right? The down payment is 50,000 times, what was the percentage here? 25% down times 0.25. Oops. 12,500. So I know that, okay, my down payment, 12,500 plus the present value being the amount that I'm paying off. So the present value is the 50,000 minus 1,250. Oops, one too many zeros. 37,500. Maybe I'll rewrite this here. PV equals 37,500. Total owing at the end of payments is the 50,000 times how much? What percentage? 15%, right? So at the end of the lease period, the vehicle is worth 15% of the original value before the down payment, so of the 50,000. Right? So at the end, once she's done making payments, this car, or new truck, sorry, is only worth 15% of 50,000. So that would be the same as what she would owe if she wanted to buy it, right? We can 0.15. I snuck it in here. Didn't give myself enough room. Times 0.15. So at the end of these payments, if she wanted to buy it, she would have to pay $7,500, right? Because that's what's still owing, right? After her down payment and her payments, she would still have to pay $7,500. Yeah. No such thing.
The future value?
That's right. Nice. So here, at the end of the N months, however long it's going to take, right? The 7,500, oops, is still owing. So what we have, we can just kind of funnel these together as always, but they're going to split, right? So it's going to go paying off some present value, but also we're not going to have this whole loan paid off, right? Because it's a lease situation. So the future value is the 7,500. So now we can use our calculator to figure out N, right? We can solve for N. So now we can have N, the interest per year, our present value, our payment amount, our future value, our payments per year, compoundings per year, and beginning or end. We want to solve for N. Eventually, we want to solve for T, right? How long is it going to take? Right? But we have to solve for N first. So the interest per year, I'll just steal it from here, was 4%. The present value, the loan amount that we get, right, to go buy this truck is $37,500. Positive, right, because we get this loan amount. Okay? And then we're making payments of $1,500. So that has to be negative, right, to indicate that, okay, we're chipping away at this $37,500. Our future value would be the $7,500, but it has to be negative, mostly because, right, we would have to pay it to pay off that present value, right, but also because the future value and the present value have to have opposite signs. Right? Otherwise, your calculator will complain. That's right. So you want to keep track of those positives and negatives, right? Thinking about how does the money come and go from me. We've got monthly payments and compounding biweekly, 26, and we're at the end. So going through, we find that N is 21.09740471. Just kind of highlight this. So we would need N equal to 22 payments. Even though it's 21.01, right? 21 payments wouldn't quite get us to where we need to be, right? So we always have to bump it up to a whole number, 22. N equal to 22 payments. Now we can find time. So N is time times the frequency, right? 22 payments times time, which we're solving for, times the payment frequency, which is monthly. 22 divided by 12, I get time must be 1.83 repeating, right? It would take 1.83 years. Because I told you to go to 2 decimal places. Cool. Nice. All right. Any questions about that one? So negative signs. So yeah, so we're making payments, so that has to be negative, but also that future value is, it has to be negative just because we would have to pay it to the bank to pay it off. Right? Yeah.
I still don't understand why the timeline has an N instead of a T. Like, there's a T next on it.
You can put,
The N throws me off because the N is somewhere else.
yeah, you can put T years up here, but because we're making monthly payments, our ticks have to be N. That's right. Good. Any other questions? Nice. So there will be one. I mean, the numbers will change, but the idea is the exact same, right? You've got a lease on some sort of, I don't think I even made it anything other than a car, some sort of car lease, right? You pay off some amount, you're making payments, and then how long is it going to be until it's worth some amount, right? So as long as you know how to deal with this situation, you'll be fine. Okay. All right. So next question. Next question is a 2-part question. And it's perpetuities, my favorite thing. You know what? I'm gonna I'll do the first part first. Show my work and then give you part B. Okay. Today is January 1st, wouldn't you know it? You decide to create a perpetuity which will pay for your TV bills forever. Your bill is approximately $80 at the end of every month. Right? And so we need to make a perpetuity, right? Set up a perpetuity that pays off $80 at the end of every month. Right? If interest is 5% compounded quarterly, how much must your initial investment be? Right. So we have to include a timeline. First, let's highlight some stuff here. Okay, so we're making, so your bill is approximately $80 at the end of every month. And we're compounding quarterly. So we can start with and payments per year is 12. Compoundings per year is quarterly, so 4. This is F1 and this is F2. Which means we have to find R1 so that we can find I2. 0.05. I1 must be R1 over F1. 0.05 over 4. .0125. So I2 must be 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.0125 to the power of 4 over 12 minus 1. We get 0.00414942. Store this. Okay. What does this timeline look like? It's a perpetuity, so it goes on forever and ever and ever. And so today, it doesn't matter, January 1st, but you could just say today if you want. We need a perpetuity that's going to pay out $80 at the end of every month forever. And so here is 1 month, 2 months, etc. Forever and ever. At the end of each month, we have $80, $80, etc. Of course, again, the same twist applies to all these questions, right? These are at the end of the month, could be at the beginning of the month. That's an easy switcheroo. Right? So these payments make up some present value of a perpetuity, right? So some present value of a perpetuity would support $80 being withdrawn every month just as the interest. Okay. Your perpetuities are your last two formulas on your formula sheet, right? You either have a perpetuity, an ordinary perpetuity, or a perpetuity due, right? Where you have to have that first payment ready to go, but otherwise they're the same. So I'll just show you that here. We have a complete timeline. So a present value of a perpetuity is nice and tiny. It's the payment amount that we need over I, where I would have to be your I2 if you had to find it, which you will. Right. So 80 divided by 0.0041494425 $19,279.77916. So the question was, how much must your initial investment be? Right. So our initial investment must be $19,279.78. That's the amount that if you're compounding every month, you would get $80 in interest that you could swoop in and pull off the top, right? And so because that remains untouched, you can just swoop in every month, pull out that $80, and it'll just keep giving you $80 at the end of every month forever, right? That's the amount that you would need. Okay. Nice. For part B, there's going to be some sort of twist to this perpetuity, right? So some alteration that we're going to make, it's usually kind of far-fetched, like every 3 months on a regular schedule. So every 3 months, right? Not every month, but every 3 months, your roommate loses their job and decides to watch pay-per-view movies all month. During this month, your TV cost triples because of your roommate. If your roommate begins his job loss cycle in 3 months, and then every 3 months after, how much must your initial investment be now? Right. So if we think about, well, up here, right, maybe I'll just add a 3rd month here. This is just to show. 3 months.
Yeah, no kidding. Why are we keeping them around?
If you just kick them out.
But then you wouldn't have a math problem. It's like those memes with like people with like 120 oranges in their basket. It's like, that's where math problems come from. Yeah, you gotta have roommates like this so you can make up good math problems. Well, you know those memes where it's like someone walking out with a huge amount of stuff in their, of the same thing, and it's really weird. Like, yeah, the one I've seen is some guy with like 120 oranges. So his shopping cart is just full of oranges. Because you know, math problems are always like, yeah, Bill has 120 oranges and Martha has 450 apples. Anyways, kind of absurd situations, but all right. So now we've got this fun roommate. Hopefully he's contributing to the social aspect.
Or at least cleaning.
So now, right, we've got this underlying situation here that we've just established, right? So this is business as usual, $80, $80, $80, right? But now, right, at the 3-month mark and at the 6-month mark, at the 9-month mark, right, we have to pay another 80 plus 80, right, because our costs triple. Thing is, we've already taken one of those 80s into account, right? So what we're gonna do is we're gonna figure out, okay, well, what do we need to add on top of this 19,000 to sustain these weird 3-month patterns of triple the cost, right? Or an additional 2 times the cost every 3 months, right? So I'll just summarize here because we didn't have a chance to do an example like this in class. So every 3 months, we need to pay an additional $160, right? 80 times 2 is $160. Right? Costs triple. But the first 80 is already accounted for. right? So here we're adding, right? What if we didn't, I don't know, pay for cable every 4 months, right? Then you would have to find out, okay, well, what's that amount? And subtract it from the amount that you need. Don't know what happened there. So, right, so we can manipulate that first perpetuity and then add or subtract whatever we need to in the second situation to get what we want.
Did you just average the 3 payments? And then,
I'm gonna guess no, just because of how the interest would work. But I'd have to try it out. Off the top of my head, I would say no. But yeah, we'll see if it works. Fun. Okay. So we've got a timeline that we have to do. So today, and now we've got 3 months and 6 months, forever and ever. So we have to sustain $160 at each of these points. These make some present value of a perpetuity. Throwing us for a little bit of a loop, right, is that we can't use I2 that we found, right? Because our payment frequency is not monthly anymore. It's every 3 months, right? That's right. So here we have our payments per year. It's going to be 4, right? Every 3 months is quarterly, just to throw people for a loop. And our compoundings per year was also quarterly. Oh, nice. Right. That's the first time that's happened. So this is F1 and this is F2. So we just have to find I1 because they'll be the same. But we can go through and try to find I2 and you'll see that they're the same. Yeah. Because every 3 months is also quarterly, right? And so we have R1 is 0.04, right? 4%, 5%. Eek. There we go. So I1 is R1 over F1, 0.05 over 4, 0.0125, right?
Can you just carry down I1 from part 8?
Yeah, you can. I just want to do it so that it's all there, right? But on the test, yeah, if you've already calculated this right on the same page, then yeah, you can just assume that you know it. If we tried to calculate I2, and this is what I suggest that you start doing, right, is just always try to calculate I2. There's no harm in doing it like this. So 1 plus I1 to the power of F1 over F2 minus 1 is 1 plus 0.0125 to the power of 4 over 4, which is just 1, right? Minus 1. 1 plus 0.0125 minus 1, 0.0125. Right, so you end up where you could have just started, but it's the safest way to get there. Right, so this is the I that you're going to use. Yeah. So now we can find the present value of the perpetuity is the PMT over I, which is going to be 160 over 0.0125. So we would need an even 12,800. Right. We would need an additional 12,800. Right. So a total of, where were we here? Plus 19,279.78. 32,079.78. That's the amount that we would need to have in the bank, right, to sustain the regular payments of $80 at the end of every month, as well as triple the cost every 3 months. Cool. So just playing around with perpetuities. Now for the behemoth question. Oh, any questions about that one before we do this one? Say that again. Yeah. Yeah, exactly. Okay. I'd say the last question, so this question is definitely the hardest of the long answers, right? So, I don't know, approach that how you will, right? It's worth the same amount as all the other long answers, right? So do your best, but don't get caught up on it. Oh no. So here, okay. So Oscar had 44 years on Sesame Street where he put away money at the beginning of every month. So he's putting away money at the beginning of every month. His RRSP earned 7% compounded monthly. Because of this, Oscar saved a good sum for retirement and now will receive payments from an annuity, earning 5% interest quarterly. Right? Notice the difference in the interest rates. At the end of every bi-weekly period of $200 for the next 15 years. So what's going on here? So he's putting away money. Well, same timeline. 2 situations, right? Because he's putting away money. At the end of 44 years, that's worth some amount. Then we take payments out of that saved amount and we get $200 every bi-weekly period for 15 years. Right? And so it's a big question, right? How much were Oscar's monthly RRSP payments? So at the end of it all, we want to figure out how much were these payments that he was making at the beginning of every month for 44 years, right? Okay. You have to use your formulas, not your calculator built-in function. Of course, you can use your calculator to check your answers. But as far as marks go, you have to use your formulas and check and show your work. All right. I'm not scared. Here we go. Huh? I just like to give you guys a little pep talk. I actually had someone email me at the beginning of this term from last term. And she was like, oh yeah, well, I've started saying whenever I see a hard problem now, I just say, I'm not scared. So I thought that was pretty funny. Because, all right, there's a lot that we need to kind of get a handle on here. Okay. So like you said, right, basically 2 different timelines, but they have to merge, right? Because what's going to happen? We know the payments that we're going to get, right? And so we know the amount that he has to have saved. right? To get those payments. And from there, we'll be able to figure out what payments would yield that savings amount, right? So we have to have them on the same timeline, but before we can, for this one, right, because we've got two situations, I'm probably just going to start with the timeline, not the beginning, the compoundings, the payments, because they're different for each side, right? And so here, I'm just going to start with the timeline. I'm wild. So we know that, okay, well, let's pretend that today he starts working at Sesame Street, on Sesame Street, at Sesame Street, on Sesame Street. Yeah. Well, it's the show. You've heard of it, I'm sure. I guess, yeah. It's the street throwing me off. Yeah, at Sesame Street, but on Sesame Street. Anyways, doesn't matter. Here at the 44-year mark, he goes from making payments to getting payments. So, and he's gonna get payments for 15 years. So we know from here to here, we have 15 years. 15 years from 44 years is a total of 59 years. If you wanted to put 15 years, that would be fine, right? Just to keep track of, okay, we're getting these payments for 15 years, right? Not 59 years. But as far as the overall timeline goes, we're going from today to 59 years. Yeah, nice. Okay. Whichever way comes naturally to you is the best one. Okay. So, all right. So he's putting away money at the beginning of every month. So here we've got 1 month, 2 months, 1 month, 2 months. 44 years, how many months in 44 years? It's 12, 528 months. And 527 months. Should have made it bigger. I don't have room. So it's making payments at the beginning of every month. And we're compounding monthly for this first part. And so let's deal with this first part first. Okay. So making payments at the beginning of every month. So how do we show that on our timeline? We have to bump our very first payment to today, right? Not at the 1 month mark. So we have a payment here, payment, 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 and then our last payment is at the 527 month mark. Pardon? Because it's at the beginning of every month. These payments, right, because we're saving, they're going to funnel to some future value. Oops, say future value, but write present value. Future value due. No, that's a big problem. Right? Future value due because the payments are at the beginning. Right? And here we've got n equal to 44 times 12, 528 payments. so for this section, right, we've got beginning. The payments per year are 12. Compoundings per year is monthly. Oh, that's nice of me. It is, right? Because we don't have to find I2. Should we do it just in case? Why? I don't know, just for fun. 0.07. So I1 must be 0.07. Oh, I'll show my R1 over F1. This is F1. This is F2. R1 over F1 is 0.07 divided by 12. 0.07 divided by 12. 0.00583 repeating. I'll store this in 1. I1 equals I2. 0.00583 repeating. You can throw that in there if you want. You don't have to. You can stop at I1, right? Just because you notice that they're the same, right? 12 and 12. Okay. All right. So now that's the payment side, right? Now we're going to get these payments. So what's going on over here on this right-hand side? So because of this, Oscar saved a good sum for retirement and now will receive payments from an annuity, earning 5% interest quarterly at the end of every bi-weekly period. So as far as our ticks go, right, we've got 15 years of bi-weekly payments. So 15 times 26 is 390 bi-weeklies. I'll say BWs. Although it was cute to talk about bi-weeklies. 1 bi-weekly, 2 bi-weeklies. So 1 bi-weekly, 2 bi-weeklies, 389 bi-weeklies. So this one, now we know the amount, right? And it's at the end of each bi-weekly period. So we're going to start at that first bi-weekly, right? 1 bi-weekly, we get $200. $200, $200, $200. These are all going to use up some present value, which is the same as that future value that we saved, right? So what's happening here, right, is that, right, we're making savings, making payments, get some total savings amount, and then we transition and we say, okay, well now I'm going to start eating out of that amount, and I'm going to get $200 every bi-weekly for 15 years, right? So how we're going to do our calculations, right, is we're going to find, we know this, right? So we can find this, and then we'll have this, so we can find the payment amounts. Right? Same situation as before, right? We can't deal with 2 unknowns, right? So we can't deal with the payment amounts being unknown as well as the future value being unknown. That's why we have to start here and kind of, I don't know, domino our way through. So I'm going to put little subscripts on here. Right, future value 1 is the same as the future value due. Put a 2 on there. I don't really have to. I'm just putting little subscripts. I use the subscripts to tell myself how the order of my calculations. Right. So here, n is the number of payments, n is time times the frequency of the payments, which is going to be 15 years times biweekly 26, which is 390. Same thing, we're going to make little notes of what's going on over on this side, right? So we're at the end. And our payments per year are biweekly, so 26, and our compoundings per year were quarterly. So 4, F1, F2. R1 is also different. It's 5%. Lots of stuff to keep track of. Right. 0.05. So I1 is R1 over F1, 0.05 over 4, 0.0125. Sneak it in there. 4 is not the same as 26, so we have to calculate I2. So I2, 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.0125 to the power of 4 over 26 minus 1. So 0.05 divided by 4 plus 1 to the power of 4 divided by 26 minus 1. 0.00191298.4. I'm going to store this in 2. I'll just make a note down here. I wrote it up above, but I'm storing this in 1. All right. This is your complete timeline. It's a lot, right? But it also is the whole problem, basically. Right? So now, right, first thing we have to do is we have to figure out what the present value 1 is. Right? And so the present value, this is just an ordinary annuity. So we've got the payment amount times 1 minus, 1 plus I to the negative n over I. We're getting payments of $200 times 1 minus 1 plus I for this is store 2. Right. So we got to keep those separate. So we keep track of which I we need to use, right? Because they're different. So it's the 0.00191298.4 to the power of negative n. We said we have 390 payments. Negative 390 over 0.00191298.4. Plus 1 to the power of 390 negative 1 minus that divided by recall 1. Recall 2. Big mistake. Thank you. Maybe I'll just steal it. 54,933.27. I don't have any more decimal places on here in my Martha Stewart version. Oh, that's okay. Thank you, Dawn. So, right, that's how much he has to have saved in order to get $200 every biweekly period for 15 years. So now, so we know the future value due must be 54,933.27. And we want to find the payment amount. So we use our future value due formula is the payment amount times 1 plus I to the n minus 1 over I times 1 plus I. Okay. Our payment amount is the one we're solving for. Our future value has to be the 54,933.27. One plus 0.00583 repeating to the power of n. How many payments? 528. Minus 1 over 0.00583. Being careful that you use that I2 from the first section. Times 1 plus 0.00583 repeating. Okay. Try not to muck it up this time. 1 plus recall 1 to the power of 528 minus 1 divided by recall 1. Okay, I'll stop and pause here. Payment 3,525.353968 times 1.00583 repeating. Okay. Okay. Basically the same. So payment amount times 3,545.918532. So the payment amount must be 54,933.27 divided by $3,545 and 0.918532. What the? Disappointing almost. 15.49197183. He would need to make payments of $15.49 at the end of every, or at the beginning of every month for 44 years in order to get $200 every biweekly for 15 years. Cool. So there is going to be one just like that. I think what we'll do is any major concerns on the short answers? Or is it okay? I'll just post the solutions. Cool. Nice. Like I said, you will be tight on time. Obviously, I talk a lot. You'll just be working, right? But you'll want to keep up your speed during the test. Okay? Oh, yeah. Here, I'll just stop this.